Here is a question. When someone says, go 3 kilometers north, then 2 kilometers east, what have they just given you? A direction and a distance. Two components. An ordered pair of numbers with geometric meaning. That is a vector. You have been using vectors your entire life, you just did not know that was their formal name. Today we name the thing your brain already understands, and then show exactly why every AI algorithm depends on it. Let us be precise about the difference between a scalar and a vector, because the contrast makes everything clearer. A scalar is a single number, temperature, learning rate, loss value. It has magnitude but no direction. A vector is an ordered list of numbers, and that ordering matters because each position corresponds to a specific axis in space. The jump from scalar to vector is the jump from one measurement to a full description of something in a multi-dimensional world. Now here is the insight that separates memorizing vectors from truly understanding them. Vectors have geometry. They are arrows in space with three key properties. First, direction. The vector, 3, 4, points somewhere specific. 6, 8, points the same direction, just longer. Second, magnitude. The length is computed by the Pythagorean theorem extended to any number of dimensions. A 300-dimensional word embedding has a length 2. Third, position in space. A vector with n components lives in n-dimensional space. You cannot visualize 300 dimensions, but the mathematics, and the intuition, transfers perfectly from 2D. Let us make this concrete in Python. Creating a vector is one line, np, array with your values. Getting its magnitude is np, linear LG, norm. Normalizing, removing the length and keeping only the direction, is dividing by the norm. 3 concepts, 3 lines of code. I want you to open Jupyter right now and run these. Change the values. See what happens to the norm when you scale a vector by 2. That 5 minutes of experimentation will teach you more than 20 minutes of passive watching. Now let me show you where you will see vectors across all of AI. In natural language processing, every word is a 300-dimensional vector, and the famous result, king minus man plus woman approximately equals queen, works purely through vector arithmetic. In computer vision, every image is a vector, a 28 by 28 image flattened to 784 numbers. In neural networks, every layer output is a vector, and the transformation between layers is a matrix multiply. And in your infrastructure work, CPU, memory, IOPS, latency as a state vector, that is exactly the input LSTM anomaly detectors use. Key takeaway: a vector is a point in space with direction and magnitude. And every piece of data in AI is a vector. Once you see data as geometry, machine learning stops being a collection of tricks and starts making structural sense. Before video 5, do 2 things: open Jupyter and create, normalize, and inspect a 3D vector, 3 lines. Then sketch a 2D vector on paper from memory and label the angle and magnitude. Both take under 10 minutes and will make the rest of Module 2 come significantly faster. If vectors clicked for you today, if you finally see what they really are geometrically, hit the like button. Subscribe so video 5 is waiting for you. In video 5 we do vector operations, addition and scalar multiplication, and we draw every single one so you can see the geometry in action. If you know an engineer who has been putting off linear algebra, share this video with them today. See you in video 5.